Today I will talk about, obviously, about OpenSIPS. And I try for the first time quite a difficult task of getting a better understanding of exactly what OpenSIPS is. Because at ClueCon here, we listen a lot of presentation about different kind of SIP engines. We talk about FreeSwitch, we talk about Asterisk, about OpenSIPS, about Kamailio, and other kind of things. And the question is, okay, what exactly is each of them and what's exactly purpose of these, generically call them SIP engines. So I will try to get a better definition of or understanding of OpenSIPS from the perspective of OpenSIPS' role in the SIP ecosystem. And then, of course, talking about the OpenSIPS role in this ecosystem and exactly about different kind of jobs that OpenSIPS can do for you in the SIP world. So first about the SIP ecosystem. That's quite a big concept, and probably it's a bit fuzzy for most of us. We are just looking at the big cloud, where you typically just see the SIP label. But we don't necessarily understand in details all the, let's say, all the elements which are in there. So I'm trying right now to structure a bit this SIP ecosystem to see exactly what are the involved elements. And I'm trying to do this from the perspective of the SIP interconnection. So basically from the perspective of the SIP switching in all this, in this ecosystem. And I have to admit, I found a really good starting point into a presentation of Dan York, like how to define SIP for telecoms in 2014, where once again, all this structuring was done in terms of interconnection. And to simplify a bit the things, I tried also to do an analogy with how the SIP, how the IP interconnection works, because more or less that's something that I suppose most of us do understand. So starting from the beginning, because interconnection, we will look from the origination all the way to the termination of the traffic. So starting from the origination of the traffic. The question is, okay, you have a device and this needs to send traffic. Okay, the first question, okay, where exactly to send the traffic? So I simplified. On the top level, we have the IP, the IP flow. Downstairs, on the bottom level, we have the similar VoIP switching. So in terms of IP, okay, you have a laptop in your network. Usually what's the next hop? Well, it's simple. It's the IP router that you have back home or in the office or whatever. So it's an IP, it's a local device, a local gateway, which provides, it's able to do all the local switching, is able to provide the external switching, so communication with the outer world. But in the same time, it's a quite, even if it's a small, but it's a very powerful device in terms of features, of skills. Because if we look at the IP route at home, it can do like firewalls, it can do port translation, it can do ALGs, it can do a lot of things. So it's not stupid at all, it's quite smart, but it has a quite low medium capacity. So it's not designed to handle quite a large volume of traffic. What's the analogy in terms of VoIP for that? Well, it's the local IP PBX that you may have again in the office, maybe back home or whatever. Now we have next step. It's the public switching. So we managed to get a way to get to the public world. So where the IP router is sending the traffic to? Well, that's simple. It's sending to the ISP, of course. So the ISP is the next element in this flow, which is able to do the worldwide switching. So it's able to talk to different kind of other routers, to exchange traffic with, it's able to do the complex routing based on services, based on classes of IPs, based on DNS or whatever. So it's a really smart guy in terms of routing, but not necessarily in terms of providing services, content. It's just about, once again, routing. Still, it's designed for high capacity. It handles a lot of traffic, and it's good, once again, in routing. And again, in the SIP world, we have the equivalent of the SIP providers being able to provide this public switching. Now, we know that when we talk about public, automatically we talk about safety, about protecting, and so on. So typically in this flow, there is something else between the local networks and the ISPs. Well, what's in there definitely is a firewall. It's something in place over there to control from the security perspective, from the connections perspective, and even if it's a device skillful in, let's say, low-level tasks, I mean, it manages simple connections, maybe it's doing package inspection, providing firewalling, and so on, is still something required to have a high capacity. All the time, the firewalls they do take a lot of traffic. Well, what's the analogy for the SIP world? Well, you have the SBC typically sitting in front of the SIP provider facing the customers. And, okay, we have more or less the switching part covered, but what's the, let's call it the termination point? Well, is the application providers. Because the whole internet basically to be useless if we don't have content. You know, we do IP routing, but what's the purpose of that? So we have for the IP world, basically an application provider can be whatever website, file sharing, whatever services that do provide content and put it on the internet. And it's similar for the SIP world. We have the same concept of application provider. That can be services providing IVRs, conferencing, different kind of services, media, typically oriented. So as a result, basically we have this kind of a flow defining in terms, once again, based on the interconnection, defining the whole SIP ecosystem. So once again, structured from the SIP originators to the termination for the traffic. Now, let's see exactly where OpenSIPS fits into this chain. So, starting all over again, we skip the SIP user agent client because definitely we are on the server side, so we don't get into that area. So starting from the local PBX. Well, typically a local PBX, an IP PBX, it's media class 5 highly oriented because even if it's in your own backyard, it's able to provide all the cool features. You have the call transfers, you have the local IVRs, you have the call hunting inside, call pickup, call transfer, and so on and so on. So it's a really smart entity over there. Well, that's not really a task for OpenSIPS because OpenSIPS is more oriented into switching routing rather than this kind of a media class 5. Anyhow, OpenSIPS cannot do media at all. So actually a more popular candidate for this position is something like FreeSwitch or Asterisk, so providing the local IP PBX. Next, we have the SBC, the Session Border Controller. So once again, it's something that stays in the middle and controls in terms of low-level features the whole traffic. And this must be something flexible and in terms of, because it connects to many kind of endpoints, so it has to deal with the interoperability with all these endpoints. So that's why you need to be quite flexible. It also has to be flexible on the, let's say, SIP provider side to provide maybe different kind of services to the SIP provider, maybe some balancing, the dispatching or failover stuff and so on. We're going to see later. But the idea it needs to be flexible and typically implements low-level features like connection-oriented, transport, routing, and so on. So it's not getting into application level or anything like that. Security, traffic control, conversion, and so on. So once again, this is here actually it's an ideal job for OpenSIPS. Moving forward, getting to the SIP provider level, well, here again, because basically we collect a lot of traffic from the endpoints, we will have on high throughput. So you need something that is able to handle a lot of traffic. Ideally, it's something that you need to scale horizontally, so basically to build clusters, and not necessarily because of the throughput, but also because you want maybe to build something geographically distributed. So it can be clustering from, let's say, multiple reasons. And my colleague Razvan will talk tomorrow more about the OpenSIPS clustering capabilities. Also, a SIP provider needs to be able to do complex routing based on different kind of, let's say, logics. Maybe in external interconnection, you want to do an, let's say, an NMP dipping or a CNAME dipping and stuff like that. And it's able to create services. So because at the end of the day, a SIP provider is providing an service. And this is also an ideal job for OpenSIPS. We'll see in the next slides exactly how it can do that. And at the end of the chain, we have the application server. Basically, that's again a really powerful content, let's say, producer, something that produces the actual content for the VoIP. So it's mainly media class 5 oriented, things that FreeSwitch can do. It needs to be able to do gatewaying, and I'm not talking necessarily about VoIP gatewaying. It can be different kind of gatewaying, like content gatewaying with other kind of applications. But in this case, it may be required, let's say, this entity to be able to, again, to be clustered, because all the time when you go up in terms of complexity of the services, definitely the capacity goes down. So in order to scale up the content, you need quite large set of servers. Automatically, you need to cluster, and of course, something to manage this cluster. And even if OpenSIPS itself cannot produce the content, it's a really good candidate for as a front end to control a cluster of such, let's say, content providers. So now let's look exactly to the points where OpenSIPS can help to zoom in and see exactly what OpenSIPS can do in those areas. So first, we said about SBCs. Typically, an SBC, on one side, it has what's called, let's say, the client side, where you have the different user agent clients directly or trunks pushing traffic into, and on the other side, you have the core server. So basically, the internal part, the ITSP. And what OpenSIPS as an SBC can do here, it's about transport protocol conversion, taking care of all these TCP, UDP, TLS, WebSocket secure, eventually aggregate, convert everything into a single protocol, depending what you have on the internal side, take care of NAT traversal things, and so on. So whatever it's, let's say, related to the IP or transport level. It can take care about the SIP security at the SIP level, like doing the SIP fraud detection, securing the traffic by analyzing and taking care that the SIP traffic is valid. It can do the bridging between different kind of networks, IP networks. And also something important, you can do traffic shaping, controlling the calls per second getting in from different kind of destination, number of parallel calls, and so on. So all these features do recommend OpenSIPS for a good candidate in terms of implementing a session border controller. In terms of SIP provider, things are more complicated. So first, looking from the SIP, exclusively SIP perspective, we have basically OpenSIPS in the middle. Typically, an ITSP gets traffic either SIP user agent clients, trunks, or via an SBC. What exactly is the purpose of this ITSP, generic ITSP? Can be like wholesale traffic, trunking solution, can be an end user SIP service, whatever. It's not really relevant. But the idea is collecting traffic, it's routing, switching it to other destinations. And on the other side of the of OpenSIPS, you have the um, application, the whole content. So who's generating the content? So generic application servers, maybe gateways, or even virtual PBXs, in this case, so hosted PBXs or whatever you want to call them. So in this case, OpenSIPS, it's able to do basic SIPS things like registration, trunking. It can act as a traffic server. It can do all the things related to the AAA, so authentication, authorization, accounting. It can act as a presence server. It has a huge possibility of implementing dial plans in different kind of flavors. You can use the scripting language, which I know that for many of you it's really something painful, but actually that's something really flexible and in terms of creating whatever services, because you can program actually the service itself directly into OpenSIPS. You don't have just simple bricks that you can put together and you get something fixed out of it. You can actually go there and program services. For example, you can implement your own call forwarding, your own do not disturb service and services like that into the OpenSIPS script. Also, there are a lot of features in terms of routing, different kind of flavors for routing, prefix-based least cost routing, actual balancing based on the load, special 911 routing. We have call queuing for implementing call centers, the OSP routing, and so on. So there are different things that you can use, once again, as a building blocks into OpenSIPS in order to put them together to create whatever custom logic you may want. In terms of ecosystem, a SIP provider, it's not only about the SIP server. It's not enough just to put a SIP server in the middle and boom, that's it, you are a provider. No, you need actually many other elements in order to get an functional, from all perspective, from SIP perspective, from business perspective, a functional SIP provider. And there are many other, let's say, entities around the SIP server that together do work in order to accomplish such a provider. So we have projects. We are working tightly together and integrated with OpenSIPS, like we have the Homer capturing interface for capturing the SIP traffic. We have the RTP proxy, media proxy. We have the CG rates. We just had the Dan's presentation previously. OpenIPS cap. We can work with Sangoma for transcoding with the cards. So there are other things, other projects, entities, whatever you want to call them, around that together with OpenSIPS, they form this kind of an ecosystem and help you build a complete solution. I mentioned these elements because they are integrated in a non-standard way. I mean, it's not SIP integration, because via SIP we can basically integrate with whatever talks SIP. But these are using special, let's say, protocols, languages, some custom things in order to make them work together. In the same time, OpenSIPS provides a lot of interfaces that can be used in order to integrate with other things. We have management interfacing of a kind of RPC. We have events, so OpenSIPS can notify you about what's going on inside. A AAA interface for radius, diameter. SQL that helps you to connect on top of whatever kind of a SQL database, similar for NoSQL, and also a possibility to interact via REST with HTTP servers. And we get to the last hop, which is the applications themselves. We said that, okay, OpenSIPS itself cannot produce content, but it helps in managing the content servers. So in that case, we have usually OpenSIPS as a front end, sitting, of course, in front of several application servers and taking care of dispatching and controlling the load on this content kind of a clustering. We can do balancing on load. We can see we can do simple dispatching. We have ability to do things more complex, like we call it smart routing, to be able to route calls particular to certain services. Like for example, if you want to do like a call transfer or you do conferencing on the servers, in that case, you cannot simply do blind load balancing because there are some restrictions. You know, you want all your, for example, conferencing, you want all the members of the same conference to land on the same server. Otherwise, it's not a conference anymore. Well, this is something that's exactly this kind of a setup with OpenSIPS in front and a cluster of FreeSwitch providing the content. That's the training that we will be running on Friday here, covering once again exactly this kind of a setup. And the front end is also responsible for controlling the traffic, throttling in terms of load and bandwidth, doing the network bridging, taking care of access control, a different kind of a thing, so to make life easier for the content provider servers, which are responsible more or less only for the content themselves. So if it's to jump to conclusions, I would say that we can split all these elements that we have in the chain in two categories, the one originating and the one terminating the SIP traffic. And basically, these are the requiring the high skills, so typically class 5 and also with the media support. And there are some elements which are more focused on carrying the traffic, so doing the whole all the switching, the routing, the being able to, how to say, to be flexible and to adapt in all the kind of crazy combinations in order to put together all the elements. So basically, if we were to go to the actual flow and put some, you know, colors, because most of the people are looking exactly, okay, what's, let's say, OpenSIPS good for, what's FreeSwitch good for? Well, so I tried based on looking once again from the interconnection perspective to put some labels. So what's exactly the best tasks for FreeSwitch? What are the good for OpenSIPS? So basically, OpenSIPS typically fits in the middle, where you do all the switching, the routing. FreeSwitch is a very good tool when it comes to originating and terminating the traffic, so dealing with the content. Noticed here that's basically the application provider, it's half-half. Mainly the entry point, it's we said it's ideally to be an OpenSIPS over there just to control the actual cluster of content servers. So once again, this the goal of this presentation is to try to get a better definition of what OpenSIPS is based on what is its role into the SIP ecosystem, because lately I noticed a lot of confusion between, okay, what should I use right now? I'm trying to do something, and I'm not sure exactly what's the proper tool for that. And at least to know where to start from, it's a very good, I think you get an advantage on that. So basically be sure that all the time you use the proper tool in the right place, and look at the SIP world all the time. Look also in the right and the left of you to see the whole ecosystem and to understand exactly all the interaction with of your system with the rest of the world. In that case, that can give you hints on exactly what you should be using. So I hope this presentation actually helped you to clarify a bit your mind in terms of, let's say, the SIP world, and not to make it more fuzzier for you. That's well, up to you. So if there are any kind of questions. One second to get the microphone.
So you can use OpenSIPS to be an SBC, but I usually use SBCs for transcoding. OpenSIPS can do actual transcoding. I'm not talking about just changing transport, but literal transcoding.
Directly, OpenSIPS itself, no. But as we had in the OpenSIPS ecosystem here, we can work with the Sangoma cards to push the traffic through the cards, to do the transcoding. So OpenSIPS takes care of the SIP signaling, but if there is a need for the transcoding, we can talk and control directly the card and push the traffic, the RTPs through that card to do it. Yeah, they're still separate entities, but let's say they are perfectly integrated, so they can work together.
Oh, that's that. Okay, perfect. That's Jason. In the ecosystem, you said media proxy and RTP proxy, and there's another called RTP engine. It officially supported?
It is. It is officially supported. There is a module for the RTP engine in starting with OpenSIPS, I think 2.1, if I'm not wrong. It is. To be honest, actually the only reason not being here, it's because they don't have a logo. Sounds stupid, but
Okay. Thanks.
Sorry for that.
Other questions? Big round of applause for
Thank you.
Bogdan.